I just want to walk you through this assignment 9 on Q learning. Now this assignment has two parts, part 1 here and part 2. So let's go to look at part 1 first. So in part 1 there are two additional Stanford videos on Q learning on an exercise they do similar to this, and this example is taken from that exercise. So you might want to watch those two videos. But again, I find the explanations a little unclear, so I'm just going to update a couple things. So there are 3 updates I want you to calculate here. In the video they calculate starting at this cell and going up and ending up over here. So I want you to calculate first the green value. So you're starting at this area, this cell, and you're going to the right and you're ending up to the right. And you'll use this formula here for updating the Q values. So your new updated Q value, and this is the update arrow. So the new Q value is going to be the old Q value, and again we're updating this one circled 0, plus alpha, which is 0.5, times the reward. All the rewards are 0 in this example, and then plus the learning rate. This is the epsilon, I show it as a y, of 0.9, so this epsilon is 0.9, times the Q value where we're going with these S primes and A primes. That's the resultant Q values. Now that's a little different here. So what you have to do is look at where you're going, the cell you're going, and you have to find the maximum of these 4 values. All these are 100, so this would obviously be 100 as a max. So this would be 100, and then you subtract the Q value you're coming from, which is just 0. Let's try this a little differently. Let me bring up another update here. So let's say we're going to update here, and let's say we're in this cell and we're going to go down to here. Okay, so we're here and we're going to go down, and let's just apply our equation here. So if we pull up our equation, let's move this up here. So again, I've just taken this equation and typed it in. Our new Q value is updated. We take our current state and we add in the learning rate times the reward plus the discount rate times the max of the next states. That's what this is. And then subtract out our current state. So I've just taken that equation and typed it in here. And then just apply. So our current state here is 0. We're coming from a 0. The learning rate is 0.5. Is given in our example up there, times the reward. All the rewards are 0, so you can always put that as 0 in our examples, plus the discount rate is 0.9. So in all of your examples the learning rate will be 0.5 and the discount rate will be 0.9. Okay, times the maximum of the next states, and here so we have to actually pay attention. There's a 20, a 10, a negative 10, and a 0, so the maximum is this 20, so we put 20 there. And then we subtract our current state. So again, when we're subtracting the current state or using this current state, we don't look at the maximum of the current state. We just look at the current state from the direction we're going, so the one that's circled. So that's the current state. And then it's this area where we have to maximize. So we plug in those values, we calculate this out, so it's 0.5 times 0.9 times 20 is 18, so 0.5 times 18. And we just calculate that, that'll be 9. So we would change this to a 9. Can't write 9 very well with this little paint program I'm using. Okay, so that's your goal. Here is to update that. So I want to know what the green value will be updated, what the blue value will be updated, and what the red value will be updated for those directions and movements. So that's part 1, just calculate those values. For part 2, you get to run this simulation, and let's open this up. Now I've got to make sure I run this job application and get this enabled. So what I have is I'm the yellow dot here on this grid, and I don't know where the reward functions are or where the penalties are, but I can move up, down, left, or right. And I have a discount rate, but I have some stochasticity. So if I try to go down, I'll go down, down, down. But sometimes when I try to go down, I'll actually go right or left. Same when I go right or left. So your job is to move around this grid as best you can. Again, you don't always go the way you want. And eventually you should find a some reward or some important value. So then once you find some sort of goal state, it'll highlight that in a color and pop you back to the beginning, and you've got to go explore some more. So then try to get over to that goal state or try to find another goal state again. And as you do, you'll get some different values here and some shading as it propagates these Q values out from this goal state. There are a couple goal states around. Now I can actually run this for a certain number of steps. So I've done 2,000 steps, and I'll run this, and I'll run and update it for 2,000 steps and do 2,000. So rather than me clicking 2,000 times, it does this. So your job is to run that simulation, explore the grid. What coordinates of value are the goal you find? You should find at least one goal. And explain why the agent doesn't always move in the direction you choose. And then using that step function, do 2,000 steps and check if all the grid cells have been explored. And then keep running the simulation until all values have been explored. So if, again, a lot of these values here are just being initialized. If I run this again, a lot of updates and a lot of the colors will change. So how long do you have to run this before it gets relatively stable? How many steps? So I've done 2,000 steps 6 times. And if I run it again, will that be enough? You have to cheat. So run those, just answer those 3 questions for part 2. So that's your assignment 9. Good luck with it.